Hello and welcome everyone to Red Planet Live. I am your host, Ashton Zeth. I am elated to be hosting the Mars Society's podcast and leading the conversation about human exploration of the universe and the future settlement of Mars. Now, as a longtime space enthusiast, I am passionate about STEM education and making humanity an interplanetary species. So thank you everyone for joining today and supporting Red Planet Live. Like always, going to kick off today's episode with just a couple Mars Society announcements. The first is about our ambassador program. Are you passionate about space exploration and the settlement of Mars? Well, the Mars Society is seeking dedicated individuals to join our Mars Society ambassador program. Ambassadors play a vital role in spreading awareness and engaging communities and advocating for the exploration of the red planet. As an ambassador, you'll represent the Mars Society, deliver presentations, and inspire others to join the mission and make humanity an interplanetary species. If you're ready to ignite curiosity and make a difference, apply today. You can learn more and apply at the Mars Society's website, www.marssociety.org, and you'll see at the very top, there's the Mars Society Ambassador Program. Fill out that application. I would be happy to chat with you about joining the program. Want to remind everyone as well, the Mars Society's new book, Students to Mars, a showcase of high school innovation and human Mars mission design, celebrates the creativity and ingenuity of young minds tackling the challenges of human exploration. Now, this inspiring collection highlights groundbreaking mission designs from high school students around the world, offering fresh perspectives and bold ideas for the journey to the red planet. You can get your copy now. Again, go to the Mars Society's website and you can get your copy there and check it out. Well, for today, I'm excited to be speaking with this individual. I had an opportunity in August to actually tour Honeybee Robotics, so this conversation is perfect timing. I'm so excited to be speaking with Dr. Kris Zacny, who is Vice President and Senior Research Scientist at Honeybee Robotics, where he focuses on developing advanced planetary robotic systems for life detection, for planetary mining, mobility, surface power, and structures. Now, he has a PhD in extraterrestrial drilling and an ME in petroleum engineering from University of California, Berkeley, as well as a BS in mechanical engineering from the University of Cape Town. He is a leading expert in planetary research extraction and in-situ resource utilization. Dr. Zacny has also co-founded Exploration Systems, which is a company dedicated to creating cutting-edge space robotics. His work has been instrumental in numerous NASA missions, including the Mars Science Laboratory and Mars 2020. He is a recognized innovator, speaker, and mentor who is passionate about advancing space exploration technologies and inspiring future pioneers. Everybody, welcome Dr. Kris Zacny to the podcast. Excited to be chatting with you.
Thank you, Sean. Super excited to be here. I can tell you, Mars Society has a big part of my space in my heart for many reasons. But 20 years ago, I was a graduate student at Cal, and I was trying to figure out what to do with myself. And then I picked up this book called Mars Direct, and I kid you not, I did not put it down until I was done with this. And by then, I knew this is what I want to do. Okay, so Robert Zubrin and Mars Society, and it really kind of changed my career. And I've been going to conferences every year, and I was kind of privileged to give presentations. And I must say, I love the diverse. Folks attending the conference, and I'm afraid the audience is gonna be easy on me, this time. So fingers crossed. Fingers crossed.
I think you're going to handle it well. I did ask my my space for some questions, so they gave me a few ahead of time as well. So I'm excited to go through those. And you already are right on track with what I was going to ask you next, which is about our question of the day. So every episode, I do a segment called Question of the Day. It's just meant to be an icebreaker. I promise no right or wrong answer. But today's question was, what book inspired you to pursue space? So you were right on it with today's question about, what books were out there that inspired you. And let's see. I would say Some of the books that inspired myself would definitely be, oh, you see it on this side. There we go. Right there, that black one on the end, which is Not Necessarily Rocket Science by Kelly Girardi. If you've watched the podcast, you've heard me talk about this book before. But I happened to be roaming around a Barnes & Noble one day, and I saw on the shelf a woman in an orange spacesuit, and she had brown hair and brown eyes like myself, and it immediately drew my attention. And from that book, I learned that, hey, you don't have to be a scientist or an engineer to participate in the space industry and to find, where you might fit. And so that inspired me to pursue my space dreams. And specifically, there was a section in the book about volunteering for roles, taking things on that, may not be a paid position, but you just want to be there because you're passionate about it. And that's actually how I ended up joining the Mars Society initially. So that would be a book that inspired me initially to pursue my space dreams. I want to make sure that we can see Kris there. I think we've got a quick connection. Kris, can you hear us okay? I think it's going to take just a second to populate again. It wouldn't be a podcast without there being, a technical issue. All right. I see that Kris is coming back. We're going to give him just a second and then get to the fun stuff. Yeah, and like I was saying, we'll give Kris a second. In August, I had the opportunity to go to LA with the Thunderbird School of Global Management, which is where I'm currently working on my executive master's. And through that program, like I said, got to go to LA, tour Honeybee Robotics. And, that was one of the favorite parts of that week, was getting to tour Honeybee. And you walk in, and I'm sure this is not proprietary information, but when you walk in, there we go. Hey, Kris, I can see you again.
All right. Sorry about it. In Airbnb.
Hey, that's no problem. We get it.
Between the internet and the Wi-Fi, we're gonna be okay. Can you still hear me?
Oh yeah, we'll make it work. Yep, I can see you and I can hear you.
Can you still hear me?
I was just explaining that. Yep.
Okay.
I can hear you. Can you hear me? Perfect.
Yes.
So I was just saying that in August, I had an opportunity to go tour Honeybee Robotics with my group from the Thunderbird School of Global Management, and getting to walk in and right in the entryway and in the lobby, you get to see the different instruments that Honeybee had built, and specifically the ones, of course, that I was drawn to were the ones on the Mars rover. And it was a little bit of like a full circle moment. Obviously, I support the Mars Society. I host the podcast. And I'm obviously passionate about human exploration and future settlement of Mars. But to see in person, in front of me, something tangible that is on one of the Mars rovers was a cool experience for me. So that's part of the reason I was so excited to chat with you today.
Yeah, and so one of the tools is called the Rogue Abrasion tool. It was designed specifically for Mars exploration rovers, and there's actually a story behind it. The MER was supposed to be a very first Mars sample return mission, and then through the different events, it morphed into this Explorer. Initially, it's supposed to be one rover, but then NASA said, well, it's better if we make it two for redundancy. And fast forward, and both of them worked really, really well. So Rogue Abrasion tool was essentially like a geologist come and managed to open a rock to reveal what's within it. And we have an engineering model that very much the same system that we have on Mars is sitting in our lobby to show us that this exploration has been going for some time, and it's been absolutely fabulous. So.
Yeah, it was a really cool experience. And kudos to Dean, the Director of Business Development, for talking through how some of the intricate instruments work. Like some of us in that group are not engineers, so I wouldn't be able to explain how it works, but talking through the mechanics of some of the instruments was really cool. So shout out to him for his patience with our group.
So rig abrasion tool has diamonds, has real diamonds that we shipped to Mars. Diamonds, as you know, are extremely hard. And to cut rocks and the basaltic rocks on the surface of Mars, it was just a good idea to bring the hardest stuff with you. And so we put these tiny diamonds, very 100 micron in diameter, and put them in a cutting tool. So these cutting tools made of diamonds managed to cut through a basalt to reveal what's subsurface. And this was, we had no idea whether actually we can cut into those rocks on Mars. So everyone was very stressed out about it. It was a first. It's easier to be second because we know at one point it can be done because somebody else has done it. But if you have to do it for a first time, there is this additional stress on you, whether you've done enough testing, whether your approach is actually going to work. And if it didn't, the impact to science would have been absolutely incredible. The tool itself was absolutely critical to demonstrating that there was flowing water on the surface of Mars. As we were going down into the lakes, we would grind into the rocks. Then spectrometers would look at those rocks to determine different elemental composition. And by this, we knew there was water, very salty water. And as we were going down towards the bottom of this lake bed, the salt concentration was changing. So we knew there was water, and this water was slowly drying out. So if it wasn't for rig abrasion tool, we wouldn't have this exact information. So our tool have shown that there was water. And then a few years later, we shipped another mining tool called IC Solar. It flew on a mission called Mars Phoenix, and it went to the North Pole of Mars, where we suspected there is ice. But no one suspected that ice is literally like an inch or 2 inches below the surface. Everyone thought, it's going to be probably 1 meter, 2 meters down below the surface. So they built this big robotic arm that would keep on digging and for hours at a time to get down below the surface. And then we landed, and rocket thrusters blew away this fine dust like 1/4 inch, and revealed that northern polar regions of Mars is like a ice hockey rink. I kid you not. I mean, you take a broom and you just slide it open. You can play ice hockey on this thing. So Mars made life easier for us initially. So we put the scoop, and as we were developing the scoop, we also realized that scoop is not gonna cut ice. Ice is as heavy, as strong as concrete. All right, you can't take a shovel and dig concrete. It doesn't happen. So we built this drill that sits at the back of the scoop, and then we push this drill against the concrete-like ice, and we managed to take ice chips. And we thought, okay, great. We have ice chips. We can send it into the spectrometers and see what's hidden in ice. We positioned the scoop over the instruments, and then nothing happened. We were looking at the data, nothing happened. No sample dropped into these instruments. No sample, not even a gram of salt of soil. So then everyone was looking, well, wait a minute, maybe we lost some of this regolith fell out of the scoop as we were positioning the scoop. And then, so we are looking on the surface of the lander, maybe we lost it. And somebody said, well, let's look into the scoop. And fair enough, the soil was literally stuck into the scoop. So what happened was, as we were holding the scoop with this icy soil shining on the side of the scoop, ice would melt a little bit and then refreeze onto the scoop. So the soil, icy soil, froze into the scoop. Okay, that's why it wouldn't fall out. So now we go, all right, we have to change how we do operations on Mars, and instead of putting the scoop up into the air, so it, so the sun is beaming down and making it warm, we have to keep it in a shade and do operations very fast. And so that's what we decided to do. Another thing that helped was our drill was not just a rotary drill. In one position, it would create percussion. It would vibrate. So if when you're taking a scoop of something, you want to, top it into the tea, like sugar into the tea and so on, you kind of shake it a little bit. So our drill bit did this kind of shaking, all right? And this shaking allowed the soil to get down into the instrument. And this thing essentially saved the mission, all right? It was a long mission, maybe 3 months, okay? So it wasn't like you had entire time in the world to come up with great ideas. You had to do things very, very fast. So kudos to entire team, kick-ass team working on the solutions to get this thing done. It was a very, very exciting mission. We learned that the ice is very salty. It has perchlorates and many other things. So great mission.
Yeah, what a learning opportunity there. Well, since we're on the topic of Mars, let's pull on that thread a little bit. In your bio, I mentioned your background specifically in mining. So I'm curious. Developing a mining industry on Mars could obviously benefit long-term human settlement and help justify some of the economic costs of settling the red planet. Are there specific or broad indications that Mars has similar Earth-like material or mineral resources?
Yeah, so not a bad planet. There is a lot of resources you can mine and make your life easier. What obviously for sustaining human presence with water, and you get methane and gypsum. Because as well, around 20-30%. So you can mine this and extract this. I would rather bring a mining equipment and processing equipment and do the mining on Mars and extract. I came from mining. I've done mining. It's easier than shipping everything, bringing everything with you.
Mm-hmm. Yeah, that would be difficult, obviously, to get all those materials and the equipment there. Well, as space missions aim to venture deeper and become more sustainable, how is Honeybee addressing the challenges of in-situ resource utilization? And what role do you envision for robotics in supporting the long-term presence of humans on both Mars, but other planets as well?
Yeah, so we have several projects related to ISRU. One of them, funded by NASA, is called the Red Water. What we did is we did a scan of what is done in oil and gas. And there is a drilling method called coiled tubing drilling. Your drill is essentially like a metal tube on a reel that you pull out and use to drill. At the end of this tube, you have a drill bit, you have motors and everything else. But imagine essentially like a Home Depot tape measure with a drill bit at the end, or garden hose with a motor at the end. It's this kind of concept. So we thought, well, it works here on Earth. It has proven itself. It has stood the test of time. We might as well use it. And then we looked at how we getting water in Antarctica. So the bases directly in the South Pole of Antarctica, the Scott Amundsen South Polar Base, and obviously people living there, they need water. And so we're wondering, well, how do they get water? The way they get water is by drilling below ice, injecting hot water to melt ice, and then pumping warm water to the surface. Some of this warm water is heated and is injected back into subsurface, and some of the warm water goes for human consumption and showers and things like this. So we combined these two proven technologies. We thought, well, if both of those work on Earth, they could potentially work on Mars. One thing of note, that the temperature of ice in Antarctica down below is actually very similar to what we would expect on Mars. So we knew there is something to this technology. So we combined the two. We built the robot, Red Water, that would autonomously drill into ice, melt ice, and pump water to the surface, and it worked. If whoever comes to our office, I can show you actual robot. It's not very big. It's designed to go 20 meters below the surface, but you can pick it up. You can literally pick it up. So it's not a big robot, but it does mighty things. Then we have other robots. Some of them also go down below the surface, but instead of melting, they sublime ice. So you have a water vapor going, and then it's being captured into the tanks, into the condensers. So a lot of different ways to do this. But that's why I'm very bullish about doing mining on the surface of Mars, because we've done it. We're using proven technologies that stood the test of time in very harsh conditions here on Earth. So I'm confident we can do it.
Two things. One, I'm going to have to take you up on that offer to come to the facility so I can see that drill. And two, what are some of the specific challenges that you see applying that drilling method on other planets, others that may not have, ice at the poles like Mars? What about other planets?
Yeah, so funny you asked this question, because cold tubing, we are flying to the moon. It's actually on its way to the moon. We have a payload called Lister, which is a 3-meter drill on the Blue Ghost lander. It launched just recently, a couple of days ago, on the Falcon 9, and it's a Firefly Blue Ghost lander. We are mounted just underneath a deck. So the lander itself is around 2 meters tall, 6 feet by probably another 2-3 meters wide, and it's got a deck, like a mid deck. So we mounted just underneath. The drill itself weighs approximately 10 kilograms, so it's not that heavy, and it's designed to drill 3 meters below the surface by injecting compressed gas. So it's a cold tubing, but it's a 1/4-inch cold tubing. The oil and gas cold tubings are 3-inch, sometimes 4-inch diameter metal tubes. Ours is 1/4-inch, okay, 1/4-inch metal tubing, but it's so strong you can't bend it out. We're using motors and bunch of gears to straighten this tube from a reel into perfectly straight tubing that drills down below the surface, and we drill by injecting compressed gas. Because moon is vacuum, compressed gas is like explosive. It's like having grenade with you. All right.
Right.
It's when we saw this thing operate for the first time, it blew our minds. Okay. because you have rocklets, you have rocks flying out. So it's literally like a grenade. It's like throwing grenades down a hole. So this compressed gas is blowing regolith out of the way, and that's how we can penetrate 3 meters down. If successful, this would be the deepest hole ever made on the surface of the moon. So fingers crossed. We've got another, I think, like 40 days to go before we land, and then we have a couple of days of operation. It's going to be very exciting. It's been in the works for almost 20 years, and we're very, very close to being on the moon.
So. Can't wait to see the update. That's very exciting, and a long time coming, like you said, 20 years. Can you talk about some of the other missions that Honeybee is currently working on? I mean, you obviously mentioned this one right now with the moon, working on the Mars rovers, but I imagine you've got others as well, maybe Firefly. There might have been one with Intuitive Machines. Can you speak to those?
Yeah, so we have, on Firefly, we have another mining system called PlanetVac, which also uses compressed gas to actually do mining. It's a vacuum cleaner, okay? There was an article in the Forbes magazine that NASA is sending a vacuum cleaner to the moon. It's sort of correct. You can vacuum clean on the moon because there's no air, and but because there's no air, we're bringing gas with us to do vacuum cleaning. So we're sort of doing vacuum cleaning on the moon, but also we sending a similar vacuum cleaner to Phobos. Okay. It's flying on the Japanese mission called Martian Moon's Exploration. Okay. It's launching in 2026. It's going to touch down on Phobos once, maybe twice. It's going to stick around for 3 hours. You have to be in sunlit areas, so you have only 3 hours to work with, and then you have to launch back again to stay warm. So that's all we have. PlanetVac needs approximately a couple of seconds to operate. So we don't need 3 hours. We need a couple of seconds. And we're going to grab some sample. And it's not just Phobos material. It's also Martian material, because there's a lot of Martian dust that has been kicked out by asteroids and so on, meteorites hitting Mars, and has coalesced on the leading edge of Phobos. So we're gonna mine that too. And 3 years later, in 2031, we're gonna be coming back. So not many people know, but this would also be a very first Mars sample return mission. Okay, we're gonna be bringing Phobos samples, and as a bonus, no doubt we're gonna be bringing Martian samples. So that's in next year, 26. But before 26, next month, there is another very interesting, very exciting mission. It's a drilling mission called Prime 1. It's going to launch with Intuitive Machines, and it's targeting south pole of the moon. That's where as you may know, there are significant water reserves. And the reason why we have a rotary percussive or hammer drill is that in case these water reserves are significant, ice is extremely hard. It's very difficult to drill, and the best way to drill is essentially bringing a jackhammer with you. Okay, so that's what we're gonna do. If we do find a block of ice, we're gonna jackhammer it and go right through and go a meter down below the surface. So that's another very exciting mission. I mean, there is non-zero chance that operations for both of those missions will happen at the same time. Okay, non-zero chance, because the Intuitive Machines needs approximately a couple of days to get to the moon. So if they launch around the time when Firefly is going to be landing, we might be operating both 3 robotic systems at the same time on 2 different locations on the moon. So what are the chances, right?
That's another record you're probably going to break. You got, vacuum, and now you're going to have 3 robots that you're, trying to operate it at once, doing 3 different missions. That's incredible. Very exciting. I can't wait to hear more updates as that happens. We've talked a little bit about, Mars and what Honeybee is doing there, and some of the other missions, specifically on the moon and potentially, other planets as well. But can you talk a little bit about what Honeybee is doing in terms of missions here on Earth? Are there some programs that are supporting science missions here locally?
Yeah, so as you know, we were acquired by Blue Origin a couple of years ago. And one Blue Origin's motto is, explore space for the benefit of Earth. And if you ever watch Expanse, the series, and I'm not sure if you watched it, and it's some people. I watched it, and it's kind of gives you. It's a good series to watch. Okay. Even if you don't really care about space exploration, it's a really good series to watch because it shows how people live in space. You have belters, people mining asteroids out there. People living everywhere, and very quickly you realize that the best place to live is our own planet. Okay, this is the best place. So what we're doing is to the benefit of Earth, and we really have to take care of our own planet, making sure that we don't have to escape and go somewhere else, because living somewhere else is not going to be as nice as living here on Earth. And just like I'm, bouncing from Airbnb, my house was survived, but was impacted by fires, and in Altadena. Let me tell you, living in your own home is much better than living in Airbnb. It's just living on Earth is much better than living somewhere else. So we do have missions that we are part of. We built various mechanisms, calibration systems for instruments, for a mission called Sentinel. It has already launched, and that one is launching next year. It's looking at the ocean currents. It's looking at the global warming. It measures how quickly the ocean's level rises. And we also now developing another part of the instrument that will be part of a mission called Crystal, which is again NASA ESA mission, which will look at the snowpack and the ice thickness both around the world. So that's how we can see how much ice disappears every year, how much water we're gonna get from snowfalls and so on. So trying to take care of our own planet first.
Yeah, that's honorable. Try to take care of our own planet while also, hey, on all these other missions on various other planets. Well, you mentioned a good point. So in the show, The Expanse, you're mentioning that there were drillers, and I see that we have a question that kind of relates to that. So the question is, do you think it's easier to train astronauts to be drillers or drillers to be astronauts? That's a hard one.
What I think is drilling should be robotic.
Okay.
And well, obviously, I work for Honeybee Robotics. So what else I'm going to say, right? But I've done enough mining. I've done enough drilling. It's really hard work. I think in human time on the moon, human time on Mars is going to be very precious. If you consider how much time actually we're going to spend sleeping, taking care of ourselves, eating, preparing food, and so on, there isn't much time to do anything else. So we might as well use our future Martians where you really need human, okay? Sure. Whereas operations that can be mechanized, can be automated, I think should be left to robots. So, for example, a robotic drilling system can make a hole, can bring the samples to the surface, and then an astronaut can look at these samples, decide which samples to take for further measurements and analysis, right? This operation requires some thinking, geological knowledge. It doesn't require a lot of muscle, but it requires this experience that astronauts can bring with them. So that's what I would do. Make it robotic, and it's not just me. It's not just me. So every so often we bring the space driller to Honeybee. Harrison Jack Schmidt, Dr. Schmidt was last man to walk on the surface of the moon and drill the free holes on the surface of the moon. And then when I asked him what would he change about drilling, without hesitation, he said, make it robotic. Okay, making a hole on the moon was a pain in the neck. Okay, and they only drilled 3 meters, and they did not drill through rocks. They drilled through regolith. They drilled through soil, like a sand on the beach. So it wasn't it's not supposed to be very hard, but it was very hard. So he said, look, I would have rather spent my time looking at the geology of the moon, picking up right samples, rather than stressing out about drilling and sweating and having very high heart rate and while doing so.
That makes total sense. Yeah, leave it to the robotics to get the complicated tasks done. Well, speaking of drilling, oh man, my eye is just watering like crazy. I see that there's a question. I'm just so excited about all the missions. I think I just absolutely my eye. So I see we have a question from AC, and they're asking, will Mars water drilling this way require a large RTG for power?
Yeah, so RTGs do not actually give a lot of power.
Okay.
Yeah, the RTGs that are currently on the surface of Mars on the Curiosity and Perseverance, they 2 kilowatt RTGs. Okay, so you have plutonium 238 that creates heat, and it's 2 kilowatts of heat. And then we use thermopiles to turn this heat into electricity. So we get approximately 100 watts of electrical power, all right? So every day you have around 2 kilowatt hours of energy, all right? And that's enough to run microwave for 1 hour.
Okay.
That's not a lot of power.
Mm-hmm.
So to get more power, you have really two options. You have nuclear, right? Nuclear reactors, and NASA is developing a nuclear reactor called Krusty. Okay, these things they can deliver tens of kilowatts at the end of the day. Right now they designed for like kilowatt, but eventually we need tens of kilowatts, megawatts of power. Or obviously solar power with a lot of storage, sort of like your solar panels on the roof with Tesla Powerwall batteries on the wall. So I think these are the only 2 options that we have: nuclear and the solar.
Greater power sources. Yeah, that makes complete sense. Let's see here. I've got another question audience submitted. This question is, what plans does Honeybee have for commercialization of their technology in non-US markets, specifically Latin America?
Okay, so it's tough to commercialize here on Earth because the cost is so when it comes to when you go to space, your focus is to make sure that your piece of hardware does not break. Okay, that's why it's expensive. That's why you do a lot of testing. That's why you select components that will survive. That's why you pay extra money to know that this piece of metal that you're buying is indeed this piece of metal that you're buying. It's sort of quality control. You're paying a lot of money for this. Whereas here on Earth, this is not a problem because you can always fix it, and the main driver is cost, right? You want to cut down on cost as much as possible. Sometimes you can take shortcuts, and sometimes you say, fine, this piece is going to break every year, and it costs $1 to replace it. Not a problem. Or I make it cheap, but I'll have to do some maintenance every month. It's not a problem. So it's slightly different. Different markets, different things are important.
Yeah, that makes complete sense. Another question here from one of my fellow Thunderbirds. Can you share a roadmap of the organization, including true entry-level positions? Clearly, this is another space bird, and they're wanted to know about the job market. But they said, can you share a roadmap about the organization, including entry-level positions? So far, robotic company have advertised entry-level positions only to require 5 to 10 years of experience. That's hard.
Yeah. So no. What we actually we have a lot of folks out of school. Okay, we have very strong internship program. We bring around 15 to 20 interns every single year. But I can tell you, it's more difficult to get internship at Honeybee than to get to Harvard. Okay, our acceptance rate is very, very low, and for a good reason, because we're looking for specific folks who are very self-driven. Okay, so we're looking for folks who are like towards the end of the bachelor's or beginning of the master's, so they already gain enough knowledge. We're also looking for folks who are very much driven, because we don't breathe down your neck. We rely on people to use the drive to accomplish things. We do provide support, so if they need help, we're providing help. But that's why it's kind of very selective. And we have probably 30-40% sort of success rate in these folks coming back to us after internship, which is, I would say, probably one of the highest industry. It's not just work, but it's also when people think alike, they actually enjoy coming to work, interacting, goof off every single day, and after 5 o'clock, and having. In fact, after 5, we have plenty of Nerf guns, and but not before 5 o'clock. It's only after 5 o'clock, and so a lot of young folks, and for a reason, and that's because they learn new stuff in schools. Okay, they learn new software, they new analysis, they new techniques. So we have this fresh blood coming every single year. And then we watch people. Some folks, they prefer to go management route. Some people prefer to go system engineering route or highly technical route. And we try to do matchmaking. So we have very good mentorship overseeing program, because we want to make sure that people enjoy working at Honeybee and people succeed. So we spend a lot of time doing a proper matchmaking. Our attrition, I think it was like 1 or 2%, and yeah, and it was because of a personal reason, like people the spouse was moving and they had to move, but people really have a lot of fun working here.
Yeah, when I was touring, everybody seemed to be working really collaboratively. Everybody seemed to be having a good time in general while they were working on their projects. But I love that you mentioned after 5 o'clock, just in case HR is listening. Like there's a cutoff time for that, so we want to make sure that we emphasize it. But no, I mean it seems to have a great culture, and I'm not surprised that it's really competitive, and a lot of people want to work there. Makes complete sense. Let's see. We've got a question about AI. The question is, how do you see or imagine AI assisting or improving your missions?
So AI is actually a very, very good thing. You would be surprised how much data is being generated every single day from all the missions around the world. In the past, what happened was you had grad students looking at pictures, literally grad student downloading an image and going image by image, scanning and figuring out whether there's a difference between the two images, whether something happened. And it was very menial work. And then, and pictures were coming, okay? So people were looking for images that were like few years old, and data that was few years old because it wasn't analyzed. So thanks to AI, we're going to speed up data processing. We're gonna look at patterns. We're gonna look at the images. We're gonna look at the spectrometer data. So it's really going to turn the analysis part into overdrive. We're gonna see discoveries happening much faster. Whereas right now, we discover something based on the data that we acquired 5 years ago. Okay, so it's gonna be more real time. So it is a very good thing.
Yeah. Absolutely, I agree. As we see AI is continuing to evolve, and with the learning model, it's constantly improving. So the rapid innovation is just going to continue, and we'll see how it is able to benefit specific missions, like you've mentioned. I see we've got another question from Kevin, who asks about the status of Viper with Trident.
I'm a internal enthusiast, and I always think the glass is half full. That's why I'm in this business, and after I stuck it around for 20 years to see our payloads fly to the moon and Mars and Phobos and Titan. The Viper is finished, okay, in terms of developing of the rover. The software is done, hardware is done. It went through all the environmental testing, and it passed with glowing colors. So it's ready. Okay. What we're looking for is a ride to the moon and the rocket, but we have a team and we have kick-ass rover. It's a matter of time. It's not if, it's when. Okay. It's not if, it's when. And I believe it's gonna be actually sooner than we think. Once we start flying these big missions, once Blue Origin's Mark 1 and Mark 2 landers start flying, once the Starship starts flying to the moon, these things, they have enormous payload capacity, enormous, all right? And Viper would be just one of the payloads, not the only payload, but one of the payloads. So we're gonna go. I'm gonna eat my hat, this hat, all right? If we don't go, but I'm 100% sure we're gonna be flying to the moon.
Well,
I don't know when.
Yeah, like you said, not if, but when. And now we have you recorded, so we can hold you to that. We've got a question here from David Thomas from the Thunderbird School of Global Management and the Milo Institute at ASU. The question is about at the IAC conference in Milan, there was conversation about the post ISS era. what does a company or a government agency, or how does a company or government agency engage in science or space science in the future without the ISS, which we obviously know there's a lot of experiments, there's a lot of research and testing that's being done. So how does a company or a government agency engage in that type of science in the future without the ISS?
So before ISS comes down, there will be other space stations. And what we are already seeing is that there is a utility in establishing a manufacturing factories in space. Microgravity is a really, really good thing, and produces flawless crystals, flawless fiber optics, new type of medicine. So there is a lot of benefits of doing manufacturing. And what we see right now is a lot of commercial companies, right, with venture funding of their own funding, developing technologies to go to space, to come back from space. Then I can tell you that 10 years from now, if you look back, the space is gonna look like you've never seen it before. Like you've never seen it. And there is no way you'll be able to predict. Things are happening very, very fast. We are the luckiest people on Earth. Folks who love space are luckiest people on Earth. We have two of the wealthiest guys in the world, okay, prepared to spend their own money to go to space and change how we explore space and make space, habitable. All right. Two of the wealthiest guys in the world. They have combined wealth of, I don't know, $500 billion, $500 billion.
Right.
All right.
Which is so much, it's hard to comprehend how much money that actually is.
And this is their vision. All right. So whoever is entering space and so on, this is a golden age of space exploration. And we are very, very lucky to have these, two individuals, Jeff and Elon, prepared to spend their own money, put their own money at risk, right, to change their humanity forever. We are very, very privileged.
Yeah, no, I agree with you. It's the time that we are in right now. We're about to witness something great. I think the momentum is starting to shift a little bit with the incoming administration, and just in the Trump's inauguration speech yesterday talking about Mars, and to see that we have again presidential support behind efforts to get to Mars, I mean, is all that we could ask for at this moment. There's so much momentum, and it's a really exciting time. So I'm optimistic about the future of space. Yeah. And I think most of the people listening would probably agree that right now we're seeing a lot of movement, and it's an exciting time. Let's see. A question here. What human mission would you rather see in the next 4 years, Moon or Mars, without worrying about preparedness?
Sorry, you broke a little bit. Could you repeat the question?
What human mission would you rather see in the next 4 years, Moon or Mars?
Both. I think Moon is closer. Okay, Moon is a bit closer. That's we're gonna go to the Moon first, for many reasons. And I'm really hopeful that we'll go to Mars this decade. It's challenging. Okay, let's not make a mistake that building hardware is difficult. Okay, you can't predict and reanalyze everything. There's a lot of things that you'll just have to test and retest, and sometimes results are not what you expected. Okay, we are working with metallic parts. We're working with fluids that sometimes behave differently at different temperatures and pressures. So even though we have supercomputers, even though we have a lot of experience. It's still difficult. Okay, it's still difficult. But I think the moon is going to be first. We have, look, last week, what happened last week? Falcon 9 launch with Firefly, okay? And then next day, New Glenn launch for the first time. It was a perfect launch, brand new rocket, perfect launch. And then Starship launched again, right? We had 3 different rockets from private companies launching in 3 consecutive days. And these rockets will be taking humans to the moon and Mars. So we're lucky. We're very lucky.
It's an exciting time. It's potentially the second golden era of space. We saw it during the Apollo missions, and once we get humans back to the moon and onto Mars, we're going to witness history at the second golden age of it. So exciting to be just a part of it. Even though I'm just a little cog, just a little grain of sand in the bigger beach here. It's exciting to be a part of it. We have a question from my fellow cohort student, Allison. Her question is, what has been the project you are most proud of, and what would be your dream future project?
So it's really, all these projects are like your kids. And what you're saying, which kid is your favorite? And I've got 3 kids. And so it's tough to answer the question. But I can tell you which project gives me most was a surprisingly exciting. So back during the asteroid redirect mission, we were funded by NASA to develop method of measuring geotechnical properties of asteroid kind of remotely. And we built this thing called space shotgun. An idea was to essentially throw pellets, like 1 inch balls at the asteroid to create craters, and some of these balls would bounce off from rocks, and that's how we would know how strong the balls are from velocities coming back and coefficient of restitution. So we created a video, put it on YouTube. Guess what? The very next moment, we start getting phone calls, and the press was saying, Honeybee Robotics is building a space shotgun, to kill asteroids. And then other press were trying to get, saying, hey, I'm outside of Honeybee. The windows are covered. I wonder if they're building this shotgun and when they're gonna release it to the public. There is a guard at the door, not allowing me to go inside. I mean, it was fun. This one small project, relatively low value, brought so much fun to everyone at Honeybee and outside. But and we got the most hits on YouTube to this day. Okay, this is a space shotgun project. And the other question, what would be
your dream future project?
Yeah, your dream future project. I think I want to do mining project. I want to get red water to the surface of Mars. I want to get down 10, 20 meters below the ground and get some water out and help to establish human base on the surface of Mars. And also moon, since this technology could go to the moon as well.
Mm-hmm. Again, like we said, it's such an exciting time, and all this momentum right now behind the space industry, and we're seeing the private companies, the commercial industry start to really blossom. Like you said, where the 3 consecutive days of launches by private companies, we're witnessing the next phase, and it's really exciting. So in our lifetime, hey, I'd say we're pretty confident that we're going to see humans back to the moon and Mars. Would you agree? Like our lifetime, do you think? I know
yes.
we put in the next decade is the goal. In your opinion, is that realistic? Are we going to see him on Mars in a decade?
Yes.
Okay.
Definitely yes.
Okay, I love your optimism, so I'm going to run with that. And anybody asked, I'm going to quote you that you said it. But Kris, it's been such a pleasure chatting with you. Thank you so much. You crushed all the questions that we threw at you. We covered a lot of topics, both my own questions and audience. And I just want to say thank you so much for joining me and participating in the conversation.
Thank you, Ashton. I had a lot of fun. It was a blast. The audience is amazing, and see you. Hopefully, all of you at the Mars conference in a couple of months.
Yes, we're gonna, I'm sure, have announcements on that coming soon for the next convention. But again, thank you so much for joining. I want to say a special thanks to our Executive Director, James Burke, our PR Director, Michael Stoltz, our friends at Liftport, Michael and Leah. Thank you so much for everybody that tuned in today, that asked questions. I love your participation. So thank you, to everybody that was listening today. And gonna finish today like we always do. As you know, the best is yet to come. Thanks everybody so much. Bye everybody.
Take care. Bye-bye.